My role this morning is to look at what we've learned or what we think we can generalize about best strategies for in a single year, essentially maximize profits. In effect, going to focus on results for the first three questions of the several you've been hearing about this morning. Rather than Daryl has done is set the stage nicely in terms of how Water Optimizer, the tool we have, works and how it's structured. What I'm going to try to do is share some specific representative results all the way down to dollars per acre and specific differences and so forth, and what that says about the appropriate strategies. The later questions we will look at later this afternoon. I wanted to start, Dr. Martin has explained what kind of inputs need to go in to do these calculations. What I want to start with is, for my examples, I want to talk about specifically what we used so that you can evaluate whether those are reasonable, how your own situation could be a little bit different, and whatnot. In other words, to evaluate whether our results make any sense, I kind of need to know specifically, I think, what went into it. The crops that we start with, and Daryl mentioned those, but the model considers, you can tell it to consider all of these choices if you wish, or if on the other hand you are interested in only a couple of them, you can consider only a couple of them. So it's pretty diverse in most states. Obviously some of these crops are not grown in all counties, but things like corn, soybeans, and so forth are available for all counties in our state. So the cropping choices are diverse as we look at what strategies are going to maximize profits. System types that are in there is, of course, sprinkler gravity at alternative water use efficiency levels. So you can describe your own system as best you can to whether it be sprinkler gravity at choices of water use efficiency levels. And if you downloaded things and looked at it, you'd see some suggested efficiency levels to use. You can consider the water source, particularly water cost, as a function of pumping depth, pressure, and of course the price of energy. It also lets you look at again, a better refined look at water cost vis-a-vis what power source you're using. So all those options are available to you, and I'll use some specific ones to share some results here yet before lunch. The results I'm going to share with you include, consider these default crop prices. I call them default in the sense that if you wanted to crank out some results, you can, for different prices, you indeed can. These values happen to be, I went in and averaged crop price received by Nebraska producers 2009 to 2011, and at least for the major crops, I didn't try to do that for things it's harder to get numbers on, such as sugar beets or sunflowers. But so we're using the key ones to focus on there. We're using $5 corn, the example I'm going to share with. That was the average for 3 years. Of course, it's 7 or more now. I got a few numbers at 7, but the basic alternatives, unless I say otherwise, are looking at $5 corn and $11 soybeans. That 5 versus 11 is pretty key, as you're going to see. The average for the last 3 years, interestingly enough, soybeans have been a little underpriced relative to the historic relationship to corn. So in my alternatives, they become a less attractive alternative than they may have been historically. Energy prices are also important, particularly as it affects water costs and net returns and total irrigation. The numbers I'm using this morning that are default in the program, if you were to use it yourself, you can see in the screen. These are based on my colleagues in Ag Economics 2012 crop budgets. Obviously, they bounce around a little bit from day to day and one part of the state to the other, but these are the numbers we use for the results that you're going to see in a moment. Default production costs that are incorporated in here for every crop is based on 2012 essentially UNL crop budgets. And so they're as current as we're able to make them as we look at the results. A key thing here to recognize is these, of course, as Daryl mentioned, the costs we're interested in are those basically just those that are affected by the decisions you're talking about. The others are there no matter what you do. Only variable costs, those that are influenced by this decision, are estimated. Although in our calculations, we define variable cost to include use-based depreciation. Historically, of course, depreciation for machinery and this kind of stuff might have been based primarily on age. Over time, I don't know whether it's a function of technology or practice, what we observe is essentially the cost of using that equipment. Its depreciated value is more a function of hours of use than age. So our results incorporate essentially depreciation for most things on a use basis. Things like the well and whatnot, which aren't affected by hours of use, are not in there. And of course, fixed costs such as land and whatnot are there in any case, and don't need to be considered to evaluate the decisions. The results I'm going to share use reduced till or no till. Other practices can be considered if you wanted to, but some form of reduced tillage is widespread in the state, so we start there as our representative case. A couple of things to think about. Production costs, of course, are going to vary widely among producers. I mean, we start with these averages. They may be pretty representative. Does that mean the optimal strategies are different also? Well, not usually. And the reason for that is what's important is comparative or relative costs. As long as you get how corn compares to soybeans, compares to wheat, or whatever sources you're looking at, those relatives are right. The absolutes could be quite a bit different, and you're going to come up with the same result. So what we've found is essentially the strategies aren't, as long as you get the relatives right, and the fact that your individual costs may be on the average a little higher or on the average a little lower, probably doesn't influence or wouldn't result in different strategies than I'm going to share with you in a moment. Dr. Martin talked a lot about the appropriately county yield estimates. That's critical to the process, and I guess all I would say to add to that is when you look at them all the way across Nebraska, county by county, and significant parts of Kansas and Colorado, and look at our best source, or Nebraska, or in this case National Agricultural Statistics, they track pretty well. I mean, obviously you get differences between producers and so on and so forth. But again, they track well enough, I think, to provide the guidelines for it. I want to start now. There's a couple of counties I'm going to share some results with you, particularly Chase and Gosper, I think. And these are the actual numbers that were incorporated in Water Optimizer to generate the values that I'm going to share with you. You see the full irrigation requirements pretty close together. As Daryl said, that's what you can reasonably expect with a fully watered yield on the average, and just something a little bit over 200. Here we go. Then dryland yields. These are all for corn. I focus on corn because it's the dominant crop. These would exist for all the others as well. You notice the difference between the non-irrigated and the dryland. That varies by where you are. It's a function of the real dryland, maybe a very different rotation and so forth. You get some very different responses. The dryland yield is based on observations primarily from NASS, and so it's key to recognize that when you're looking at the response to irrigation, what you want to key on is how much water what the yield of the irrigated crop would be if you didn't put any water on it. Because it's got a different plant population, all of these kinds of things. So, and you see, particularly in a couple of counties, they're quite a bit different. The irrigation requirement at 80% efficient, that's a good system. at least in our suggestions, sprinkler could be 0.7, 7.5, 8. Maybe a little better than 8, and in some cases 8.5 or so. So we're using a pretty good system, and the results that I'm going to share with you. I drew these as actual corn curves for the 4 counties. Of course, down here is dry land in bushels per acre. You can see Chase, of course, it basically follows rainfall, not surprisingly. And Chase, Gosper, Buffalo, and York in terms of the dry land expectations. You get out on the other end in terms of what, they're all, most of them are converging at just over 200 bushels per acre. And of course, in those counties which require less irrigation water, you max out at lower requirements. So those are the actual curves that we use. So let's turn now to talk about results and strategies. This particular slide happens to look at, this is Gosper County, and the dark red is a deficit irrigation strategy. I say deficit irrigation plus dry land, and the reason for that is under the, if we optimize, what the optimum turns out to be is you deficit irrigate down to a certain point, and then go to your best dry land crop. An intermediate lower water using irrigated crop doesn't enter in this particular case. So the purple is, and of course, I'm specifying the available water supply, and you could simply, for convenience, as a percent of the full irrigation requirement for corn, and which is the dominant, most profitable crop. So if I got all the water I need, I'm going to get this $521 returns over variable cost at our $5 corn. And green, the green bar is a full irrigate corn, and so what the green corn, or the green bar says is, suppose I follow a strategy that says, what I want to do, whatever my water supply is, I'm going to decide in a normal year how many acres can I expect to fully irrigate with that water supply, and the rest I go to dry land. In other words, you don't deficit irrigate. You go for full yield in all the acres that you choose to irrigate. So those are, when you got a full water supply, of course, that the 2 bars are the same. Now we cut down to, suppose in an allocation system, or what you had available was equivalent to 80% of the full requirement for corn. Of course, both bars go down, but the deficit irrigation alternative is now what 70 some dollars or so better than saying, hey, I don't like this idea of deficit irrigating. I'm going to just go for full yield and irrigate as much as I can. And then that pattern, I go to 60%, which would be a 40% reduction in water supply that you'd like to have. I got a $90 difference between those two. But still, deficit irrigation. Here you got $90 difference. Now when I get back to just 40% or 60% reduction, they're starting to come back together again. But still, deficit irrigation is clearly the preferred strategy, and you would never, with limited water, ever want to go for fully irrigate however many acres your water would allow you to fully irrigate. So do note that. The other thing to note is that I think is useful, and it's been shared in several ways here this morning, is look at the difference between 521 at a full supply and a 20% reduction. If you had an allocation, reduce your supply by 20%. Even at $5 corn, that's 20 some dollars an acre. It's pretty tight up on that front end, and it becomes more serious, of course, as the requirement, the supply goes down. Now let's expand the strategies and consider a couple of other things, again for Gosper County. One of the things we have the folks consider is let's go to all irrigated soybeans. That's the green bar. So essentially, we devote everything to irrigated soybeans. At any water supply, certainly at a full supply, corn dominates. You're not going to choose that lower water using alternative. Not surprisingly, not most attractive here, but even when you get over to a 60% supply, you still got the deficit irrigation alternative and a corn alternative. Soybeans don't become competitive in this case until we got a really minimal supply. And at these price relationships, $5 and $11, at 40%, okay, it's pretty much the same. That's what the strategy would, what those slides suggest is, don't, when water's limiting, don't fully irrigate your, I'm going to call it the preferred crop. A lower water using one isn't necessarily more profitable. You may be better off deficit irrigating, going to a dry line choice. Incorporating those, whatever the optimum choices are for the water available for the two counties now. Here my point was to compare essentially profitability of irrigation, if you will, or returns between Gosper and Chase, and you can see the differences. If I have out here, if I get 14 inches or so, I'm going to max out in Gosper County. I guess that's here. It's going to take more than that, 16 or so, to max out in Chase County. These are pretty efficient systems, and quite a bit of difference in terms of dollars per acre if under an optimal strategy to those two locations. Okay. Now the next thing I want to talk a little bit about is the crop, the optimal pattern. Again, this is Gosper with those numbers. So we're saying, okay, deficit irrigate. Well, how far do you cut back? We're basically talking about, given real numbers, where on those curves that Darrell shared with you are you likely to end up? Well, at the prices and cost I've talked about, you start out, above 9.2 inches, which is 67% of the estimated requirement. Choose to irrigate 130 acres of 130 acres, and actually it's 130 acres of corn if I looked exactly at those results. Below 9.2 inches, plant remaining acres to dryland soybeans is what turns out to be the alternative. So what happens is, if I've got, I think of it as at least 2/3 of my water supply, and corn is your most attractive general crop. Deficit irrigated, put all your irrigated acres to corn. If your supply for an average conditions drops below 65–70%, you start looking for alternatives. In this case, the best alternative happened to be put some acres to dryland soybeans. With other prices and other situations that may be something different. But the point is, you stayed with your dominant crop until you'd cut back 30% or so. Chase, you end up with, again, a very, in this particular case, it turned out to be optimal to start going to your best dryland alternative, shifting some acres to it after your supply was about 75% of what you like. So in this particular case, you started cutting back a little bit sooner, but given realistically what numbers you have, you still think of that as, if you got at least 70% of a full supply, don't cut back acres or go to alternative crops. Both Chase and Gosper. The next thing I want to keep you folks late for lunch. If you can probably tell, I like to eat too, so it's not real likely. But I'll want to talk a little bit about price sensitivity. This particular slide says I looked at a deficit case, where you'd like to have 12 inches or so. I said, what if you had about 8.3? Then if I had a $5 corn, $11 soybeans, and 8.3 inches of water, I'd put 9.2 inches per irrigated acre of crop one, which is corn. I would devote 118 acres to corn and just a little bit to dry land. Maybe that may not even be enough to bother. You're going to go primarily to irrigated corn at $11 and $5. Actually, at $5 and $8.80, which is a 10%, I think, reduction that was, the result's the same. You got to get soybean price relative to this price of corn has to get significantly higher, at which point you're, at 8.3 inches, you'd be fully irrigated soybean, or all acres to soybeans. The results are really, really sensitive to how, in this case, for these two choices, the relative prices, how the prices compare. Switch it on you a little bit, same case, but let's fix soybeans at 11 and vary corn. And so at $4 corn and $11 soybeans, if that happened, at 8.3 inches, grow all irrigated crop 2 soybeans. 5 is the original result. At $6 and 8.3, it's all irrigated corn. Rather than the 9.2 alternative, you draw back and stay with that irrigated crop at when corn price gets to 6. So that's what we find for these specific cases. This happens to be just another example. I'm not sure I need to dwell on this, where I looked at a little wider. I happened to look at 450 corn price. I wanted to do that because my colleagues around the country that do longer-term price forecasting are suggesting that longer term is likely to settle around 450. Did I have a question? I heard the question. The question was, what's the assumption about starting soil moisture? Dale can correct me if I'm wrong, but again, this is a planning result for an average year. The yield results are, expectations and so forth are based on a 30-year simulation. So in effect, I think it's probably fair to say it's assumed to be something close to the 30-year average. Is Daryl here? Yeah. Again, one of the things we're plugging in real weather is a different task. So where does this lead us for guidelines? Optimal strategy to plant most profitable irrigated crop on all acres, as long as the supply is about 70% or more. Below that, you shift to either your best dryland crop, some acres, or in some cases, a secondary lower water using irrigated. I tried to look at, without dwelling on where soybeans need to get, pretty clear if the relative price of soybeans began to approach 2.5 times the price of corn, soybeans become very attractive fairly quickly. Now at 11 and 5, they're not quite there. At 11 and or at 5 and 13 or so, it becomes an attractive choice with all its, and there's some advantages to that from a water conservation point of view. The other issue with respect to guidelines is, we found, we've been fiddling with Water Optimizer now for whatever it is, 7 or 8 years, and research longer than that, the general guidelines aren't very sensitive to location and, localized factors, if you will. They, this general recommendation, if you're above 70% supply, applies very, very widely across soils, system types, and so on. Of course, different soil or different system type determines a different requirement, so 70% of of a system on sand is going to be different than 70% of another system, but interpreted correctly, they're pretty generalizable. The particular example I shared with you is continuous corn with appropriate chemical costs and yield expectations. We do have an option, the water optimizer, for corn following soybeans, for example, where the costs are adjusted as a function of chemical requirements, and the yield is also adjusted. We built in some of the evidence that there's a bit of a yield kick associated with corn following soybeans. So that option is there, but it's not embedded in what I shared with you this morning. The question, I think, was, do we deal with drip irrigation at all? Not directly. Darrell, did you want to say something about that, maybe, or Chuck? After lunch, one of the things we'll be sharing with you is a look at kind of economic incentives for investing in system improvements, not in a big way, but as one of our quotes miscellaneous topics, and that'll speak a little bit to that question on the grounds that to steal my own thunder, when you get a really, really limited water supply, no matter what system you got, most of it is going to the production of corn, so the payoffs actually go down by